Many students, teachers, and others have preferences for how they'd like to represent mathematical symbols. Let's think about a problem involving a function. For many familiar with math, their instant thought is to call it f, or g, or h, or maybe y. What about a word problem involving a distance? Would you call it d, or lowercase l, or uppercase L, or x, or b, or h? Note that some choices may end up being more confusing or less confusing. What about math vocabulary? Does it matter if someone says regarding a fraction, there's a top and bottom, there's a numerator or a denominator, or a number and its divisor? Should you call the fraction a quotient? The way that I choose to view mathematical language is as a set of conventions, which may be simple or formal, loose or exact, preferred or not preferred, new or archaic, all of which students must navigate, all while figuring out how to actually compute the math and understand why it's computed in that way. Therefore, math notation is an accessibility issue, and keeping this idea in mind will help students learn, or more formally, reduce cognitive load, so that they can free up their attention on understanding what the math is for, rather than pondering what a mathematical statement represents. Also, earlier I mentioned I, so let me introduce myself. My name is Malik, and I am an undergraduate physics major from The Ohio State University, and I am currently participating in the Growing Up STEM, or CIDR, research experience for undergraduates at North Dakota State University. But back to notation, how does this idea of cognitive load manifest? For the purposes of this discussion, I will refer to a paper that analyzed the history of math notations and the principles that individuals have used when devising their own notations, some of which have survived to today. This paper, An Analysis of Mathematical Notations for Better or for Worse, by Biltek, K, and U, published in 2015, devises a theory to organize principles and analyze the interactions among them. The paper then examines the validity of their model by ordering the principles in certain situations and then ensuring that the model is applicable to various examples from common math contexts. Now, you might be thinking, why should people who understand many levels of math decently well care? Well, first, as someone with expertise or insight that you want to share, you should try to provide that insight in the best way possible so that it can be understood by as much of your audience as possible. Also, it'll make everything you do more readily verified by others. Thus, it is very important to explain your notation choices, especially in the specific context of what you are trying to accomplish, especially when different fields choose conflicting conventions. For example, spherical coordinates have swapped variables between math and physics. Even if you aren't a student who is taking math and physics courses at the same time, it would be beneficial to explicitly label or explain what each variable stands for and where it occurs. Doing all of this will help you make more conscious and therefore informed decisions. You might be thinking, why can't we just make a unified and all-comprehensive math notation system? 1. It limits the ability for expression by anyone who uses math. While this might be good for communicating with others, it also wouldn't be able to be adapted for specialized uses in certain math contexts. For an example from physics, which is again expanded on in the Biltek KU 2015, there are 3 ways to write Maxwell's equations, which are very important in the field of electricity and magnetism. The 3 ways are differential form, integral form, and this very compact one. But the thing is, each of these forms has its own advantages and disadvantages, depending on the problem or context at hand. So, being able to make an informed decision as the writer in a mathematical communication situation might be really important given this specific situation. Or not, but it's always good to assume that it is at least somewhat important. Also, according to Biltek KU 2015, an all-comprehensive notation system has been tried a couple of times and has always failed. So, what conventions and concepts can you adopt to make your math grammar more clear? First off, just thinking about it should help. But if you really want to think super detailed about complicated situations, you can steal a page from Biltek KU 2015, who stole a page from the linguistic optimality theory. Optimality theory involves choosing a set of principles that languages should follow. Of course, you can't follow every principle at once. So you order the principles by their importance. Then you count up how many of each violation is made in a word or phrase, and then you can then choose the option that minimizes the amount of important violations. So in this math context, the principles and things that you can violate are Unambiguity. No two objects should have exactly the same symbol. Conventionality. For every notation that is unconventional, one violation is counted. This is because using established conventions may help your audience tap into their experiences with a specific context. Being aware of conflicting conventions will help your audience separate a distinct context from the one at hand. The smallest number of rules. Fewer rules hopefully means that the rules are more straightforward and have fewer exceptions or special cases. Shortest length, because sometimes being more concise is helpful. In each situation, you should use the collection of notational choices that has the fewest violations of those principles. In conclusion, notation of math is an accessibility issue. Like all accessibility issues, making more informed and accessible materials provides a better experience for everyone. Just being conscious of conflicting notation conventions and possible ambiguities will help make the notation that you create more easily digestible. Additionally, coming up with various examples on how to write a statement and then choosing the one that is the least problematic is a good method to make sure your notational choices will be the clearest for your audience. If you, by chance, want to discuss any of your thoughts or ideas about notation in math, please feel free to email idrismalik44@gmail.com. Hopefully you enjoyed listening to this, so be sure to like and subscribe to the following organizations: Growing Up STEM and Interdisciplinary REU, STEM education supported by NSF-DUE 1852045. And for the music credits, A Stroll Through the Grove by Malik